So Trilio and this intelligent recovery platform is basically building on top of Ben's MKE environment, multi-MKE environment managed by Mirantis Container Cloud. And we are basically using, before we start into my presentation, we're basically using everything which is managed by the platform, by MKE. So they are doing the heavy lifting, and we are just another very helpful application on top of Ben's infrastructure. It could be, in this case, it's a multi-cluster architecture, and it can be also hybrid, as Ben mentioned. But what is actually Trilio? I mentioned before, it's an intelligent recovery platform because there are a lot of tools they can do backup of something. 10 years ago, 20 years ago, it was copying a file from A to B and big hopes afterwards if you can actually recover your file, because everything had to be very identical and an identical twin, to be honest, if it should work. But these days, it's completely not applicable because things are very, very much agile. You have a lot of different distributions, hyperscalers. You have a lot of different storage providers and hardwares underneath. So to have the identical twin on your backup side, on your cold standby side or something is very rare because everybody wants to be agile. Everybody wants to save costs, maybe to have a cheaper hardware vendor here, as compute nodes, storage nodes, these kind of things. So the actual recovery platform has to handle it. And that is basically the way of saying, okay, an intelligent platform should be able to cover all of these complexities, which the normal user don't want to have anything to do with, right? Because this is our task. As you see, the main platforms are Kubernetes and OpenStack. And in this case, we also support both products of Mirantis and all the others, because maybe you want to swap between them. So let's have a look about Trilio for Kubernetes, because we're talking about Mirantis Kubernetes engine. So we're talking about Trilio for Kubernetes. What is our product? Our product is a software which you basically install like a normal application. It's not a SaaS software, it's a regular software just installed on MKE, like a regular application, as I said. It's agentless, so you don't need to install any agents to your applications or your workloads. If you do a backup, it's non-disruptive. Nobody wants to have a 5-hour downtime or something for taking a backup. And it is built the same way. It's designed for the cloud. It's built for the cloud. It's built on the cloud, which should inherit all the very important topics like multi-cluster, self-service, no bottleneck. If the cloud scales, Trilio scales. So everything which is basically normal these days and which you would expect from an application. And the last bit is very important. We use as our backup format, which is basically, including your data, customers' data, sensitive data. It is an open universal schema, which is a QCOD2 image. So you can use all the scanning tools you have for viruses and malwares. You can mount it to Linux if you don't like Trilio anymore. So it's a very transparent way of backing up in a certain format your data. So there is no self-invented proprietary format nobody can read and handle, and you need Trilio to read it. No, it's a proven since many years in the Linux world QCOD2 image format. So what are we talking about today? Before we dive into the demo later on, let's explain what is actually the difference. As I mentioned before, many years ago, the data-centered recovery was actually the way to go. And yeah, basically people were just caring about disks and data and, for example, taking a snapshot of a VM or these kind of things. But this is just the halfway, right? This is just half of the thing you should have these days to recover entire application landscapes, for example. So the world has changed, as written on the board. You need an intelligent way. You need a smart way of recovery. And what does that actually mean in a short summary? So the method should be intelligent. So from an administered service kind of, somebody has to do it, an expert and backup expert or something, a siloed team has to do it with superpowers on storage level. But in most cases, they have no clue about the application. They are doing jobs from a ticket system, and if they have to recover something, they have to ask somebody to test it. So it should be self-service, right? Same for the responsiveness. So the ticket is there, the backup team is maybe the bottleneck because they're overwhelmed with the low amount of work, because we're talking about DevOps these days, so there are multiple different requirements when it comes to backup and recovery. So it should be automated. It should be self-service or orchestrated even. So talk about orchestration. Back then it relies on experts. They know exactly what to do. They had maybe spaghetti code in place or some scripts or something like that. These days, Ben mentioned it, we're talking about orchestration tools like, Chef, Salt, Ansible, Terraform, these kind of things. So basically, we can use that. We can leverage that. So same for the data. If we talk about applications, back then you have to know, or this guy's or the old method is, you have to know what to back up. And maybe there's a mistake. Maybe you forgot half of it. There were 2 disks instead of 1, or you forgot about the metadata. If you do it the intelligent way, there is an automated discovery of what is actually application and what belongs to it. And then you can test it, you can prove it, and you can bring evidence. Recovery time, because you do it manually and by a certain person and the other person is doing it differently, it's kind of unpredictable. If you do it automated, orchestrated, you test it, you can actually see what's happening and you can prove it as well. To, for example, regulators. If it comes to compliance, you need evidence to these authorities saying, hey, we have done the backup, it's orchestrated, it's written in a policy, it's exactly doing this, and this is the evidence. And this is what they need. They need something written down, and there is no variation in it because there's no human intervention. It has been defined by humans, but it's done by machines. So basically, there's no way around to make any mistakes. Okay, let's come to the last one. Last one, but my slide goes forward, is the topic of use cases. We're talking about using Trilio for backup and recovery. Obviously, we're a data protection platform. We're also talking about disaster recovery. So basically the most urgent case of a backup and of a recovery. So in most cases to a completely different cluster. Also application mobility, in case you would like to move your applications from one platform or maybe on-premise to a different platform on one of the hyperscalers, for example. So you can move entire applications. This is basically a backup and a recovery, but in a let's say, intended way. Same for migrations. One of the biggest examples always, if you have different versions of a cluster, you have updated your cluster here, and you have a new cluster with a new major version there. You have tested it, and then you can move and migrate your applications over. And also a big topic these days. Last year was a big spike in the in cases. Also this year, ransomware. So you would like to recover from ransomware. We're also there and support this and can help you with that. So now, in terms of Trilio, let's dive a little bit more into the kind of architecture, and then later on going into the demo. Okay, what is Trilio actually from an architecture perspective? So imagine we have cluster number 1, like in our demo later on, and you have an application running on that cluster. It's in this case, let's assume this is a database application, and this database application is being backed up to, for example, an S3 bucket on Amazon, for example, with all the ingredients. So not only the data, also the metadata, because people spend a lot of time defining all the, secrets and config maps and whatever. So a lot of work went into it. So it's the same way because it made the application available. So that's also very important to understand. It's not only the data is there. In most cases, your customer wants to access the data. So it needs ports, it needs secrets, it needs everything which makes this data available to customers. Because otherwise you have restored maybe your persistent volume, but nobody can access it. So the service is not up and running, customers not happy. So imagine something goes wrong. You can take one of the backups or parts of the backups and restore to cluster number 1, and everything is fine. As you said, you can restore the entire application or bits and pieces of it to a new namespace or to the old namespace. It's completely up to you. But now imagine this cluster is down. or it's untrustworthy because maybe you had a ransomware attack, you can also take the same backup and restore to a different cluster. The only thing you need is basically have this cluster ready, have MKE installed, install Trilio. It's basically one command, and then tell Trilio where's the backup. That's the only thing you need. So there's no need of backing up the backup application configuration. Everything we need and all the configurations of your application is on that backup target. So nothing. So Trilio itself is stateless, which is very handy when it comes to time pressure and these kind of things. Now we're diving into continuous restore, and the topic today is rapid recovery from failure. And we're talking about rapid recovery. There's time pressure, there's maybe a loss of business, and these kind of things. And Ben also dived into it. What is, I see there's a typo, RTO versus RPO. So RTO basically is a measure of the amount of data that the business can afford to lose. So for example, I can lose maximum 2 hours, 10 hours maximum. This is what is being tolerated, and maybe by government, whatever compliance rule set. And when it comes to RPO, this refers to the amount of time your organization can afford to lose following a disaster until business operations can resume. So how long does it take to basically be back alive, be back online? And this is basically equal to your SLA. If you say to your customers, your service, we promise you your service will be up for a certain percentage, and you have to solve that. And this is basically the RPO value. And this is where Trilio also covers both things, but continuous restore especially is pointing to the RPO. So what does that actually mean? Because we have to understand what actually influences these kind of values in an urgent disaster, for example. First of all, if you have a disaster or one of your services down, who's actually doing the recovery? So process-wise, it has to be clear. Is it automated? Do I have to do anything? Or is it, so I have to call somebody? Is there an on-call duty? Or these kind of things. So it takes some time. Then how fast is the bandwidth from, for example, the backup location to the target cluster, or from one cluster to another cluster? So these kind of things can play a role if the cluster is far away on a different region, for example. The amount of data, are we talking about one application with just 1 gigabyte of data, or is it hundreds of applications which are business critical? And also this source cluster, which is apparently down, is that maybe completely different to the target cluster, to my cold standby backup cluster somewhere, for reasons, for good reasons. The complexity of it, as I mentioned before, is it maybe a different version? Has it used different storage classes? And is there a completely different situation up there? And also, how likely is it that somebody maybe with manual intervention makes mistakes? As I mentioned before, if it's tested, proven, automated, it should be tested before. Nothing should go wrong. But if something like a human has to change something in the configuration before restore and stuff, that's maybe a point where potential mistakes can happen, and so on and so forth. So there are just some examples what can happen, and then you have no time, you have pressure, customers are complaining, maybe tomorrow you're on the newspaper, right? So that's something to avoid and to also incorporate into your thinking. Now let's talk about continuous restore in action. So what is continuous restore? Continuous restore is basically an enhanced feature of our portfolio, staging data on your clusters to be used in case of an emergency. So you save the time of transferring over the data in an urgent situation. So what will happen? What we need is, we need TVK, so Trilio for Kubernetes, installed on all these clusters. Obviously, we need the Trilio logic there. We define a policy, which is a regular policy in Trilio. There's just another sub-menu defining the continuous restore policy. So there's not an additional feature. If you are able to use Trilio, it's all in. You can use all the features. And we store regularly the backups on the, in this case, S3 bucket or blob storage or Google storage on your backup repository in the middle. And then the clusters on the right-hand side will check, hey, is there a new backup for me? Is there some data I have to stage on my storage nodes or something to be able to recover in actually no time? Because this link could be, small link. You just, the higher the data is you would like to restore in an urgent case, the more you have to wait. And there are just some things you could easily erase out of the equation. So how does it look like? We store the data, and then we distribute them basically to your, can be 1, 2, 3, or maybe 100 of clusters, and we stage the data there, waiting to be activated. So imagine you have maybe a database, a MySQL database, which is important, or some other stuff, and it has maybe already 10 gigabytes. Imagine maybe how long it takes 10 gigabytes just to transfer over the data manually or in that specific moment. If you can save that time, save it. And it makes things easier and your service up and running much more quickly. So now let's see how our demo setup looks like. As already shown, we have a primary MKE cluster, and we have our backup repository. In this case, we used AWS S3, and we created 2 buckets. One is the event bucket, which is used by Trilio for coordinating the continuous restore policy, so Trilio internal communication. And one is the backup target where your backups are being stored. And we have one secondary MKE cluster as a potential target. Could be, as I mentioned, much more. In this case, for the sake of being, having a good overview, we just use this one. What we did is we have one application, in this case, a MySQL application, a small one, 200 megabytes big. And we took in total 4 backups. And as you see here, it's stored there, and then the cluster says, hey, there is a new backup for me. I have to stage them on site because we defined the policy saying 4 is the minimum I would like to have here, just in case. Can be 1 full, can be 3 incrementals or 4 full backups, completely up to you. And we have them ready to be restored on that site. Okay. We call it consistent sets. So a consistent set is basically equals a backup. So one backup consists one consistent set, which includes your persistent volumes, your actual data. So there's no metadata, so no secrets and something like that involved. We're currently covering the actual data, which is the biggest amount of data in this case. Okay. Then let's go to the next slide, which is actually my demo video. So this is our Trilio application view. You see a lot of labeled application in the middle. And we have our K8s demo app application, and we create a backup plan. A backup plan is basically the policy, what has to be backed up, where. So we have to go to the certain namespace. We give our backup plan a name. Can be any name or following a certain naming convention, and we select our target where it should go through. We also have a feature where you can actually back up the used container images, just in case you want to make 100% sure, even if the repo is down, we would like to be able to restore the container images. But in this case, for the sake of the speed and saving capacity, we're skipping this case. You can also put in all the scheduling policies for scheduling regular full incremental backups and also retention policies, like you do for every backup solution. We see our application here again. And in the next context, we see, hey, we have the so-called remote TVK instances. So main is the one we are currently at. And the secondary is our target cluster, where Trilio should stage the data to be able to be restored. And on the right-hand side, we have the continuous restore policy, which defines how many data sets, consistent sets, you would like to stage on that end. This will be created now. Takes a second. And the continuous restore plan will be stored on this one and also on the event target I've mentioned before, because from there when there's a backup also available, the other cluster will see, okay, there's a backup available. I have the configuration from that event target. I know what to do because I know I have to stage 4 consistent sets there. And yeah, basically it's doing its job. So now we are executing one backup based on that backup plan. And I copy it because I would like to do 3 additional ones for the sake of our demo here. So what happens now? We're taking a meta snapshot, which is important to know. This is the place where all the metadata, everything which belongs to the application, so secrets, config maps, whatever you have defined, the port configuration, everything, and also the data, the actual persistent volume will be. So you see the entire application, so Trilio is application-centric, because that is what matters. You would like to restore your entire application, your entire workload, your service, whatever you have there, the entire thing, not only the data, because you would like to have a comprehensive backup here. And at the end, I fast forwarded a little bit. We uploaded the data and the metadata to our backup repository target. And at the end, all the workers, our worker containers will be cleaned up. So we do not leave anything on your cluster. It's just on demand for security reasons. So now we see in the backup plan section that our continuous restore backup plan is in progress. So it's doing its job. And we see, okay, the first backup is there. Perfect. It's available, which is always a good thing. And we also have our first overview. Now it's in progress. We will see in a second that I have created 3 additional ones. So we have in total our 4 consistent sets. See also statistics. There we go. Outbound means from the main, it's outbound, and our target, there will be the data shown in the inbound section. So it has now 4 consistent sets existing on the cluster. So it's staged, it's there, it's kind of hidden, let's say, able to be used for a restoration in case something happened. This could happen manually or orchestrated, automated. You see here on the secondary cluster or target cluster, these inbound consistent sets are available, and you see them here. They're all available status, so they can be used for a recovery. This is what we do. We restore now because we have an urgent scenario. In this case, I do it manually for the sake of showing. Now you give the restore a name and also select the restore namespace where this application should be placed to. Looks like I couldn't decide what to do first. I'm always very patient with creating names. There we go. And also select the namespace. We have a lot of switches here, which we can use for a variety of different use cases. In this case, we leave it on default. And we start the restoration process. And we will see now that Trilio is validating, okay, do we have that consistent set available? Okay, cool. Do we have the metadata? Okay, what does the metadata says? Does it have this the image already included, or does it needs to be downloaded from a repository? In this case, it will be the repository. You will see the validation is done, and in this case, only the metadata will be restored because we have the data already there. So you save the time of downloading it from somewhere. So it's a big benefit. In this case, pods will be spinned up and secrets and all the necessary bits and pieces get created, and the data will be basically mounted to the pods. So now we go into the namespaces and we check for our restore namespace, which we have created. I named it quickly app restore or quick app restore, and we check the labels and we see that our backup application has been recovered. Let's see what's in there. So the application details, we see we have secrets, deployments, replica sets, service, system volume claims, and in total 4 pods created. Now, Ben mentioned already, let's see how this looks like on Lens, because you can also use Lens for the sake to, see multiple different things at a glance. So in this case, you see the nodes. Ben already explained that. And we can also see all the Trilio CRDs at the bottom. In this case, we see, if we go into the right namespace, our sample application on the source cluster. You can grab all information you need. You can edit things. We see all our backups we have done so far, including our 4 backups for our continuous restore. When, how big. We also see our targets, event target, and our backup target, sizes. And now we're switching to the secondary cluster. And we will see our continuous restore policy, basically defining what this cluster should do, how many consistent sets it should maintain. And also a lot of information, as I said, at a glance. You don't have to type hundreds of commands in. We see our consistent sets here, the sizes and the availability, the creation times, timestamps, these kind of things, which can be very interesting. And at the end, quite interesting, you can also edit all the things you see, basically, with a very beautiful, I like that, colorful scheme here to identify things much easier than maybe with other terminal emulations. You can save and edit things. So quite handy for all different kind of cases. And we also see our application live here in this context, in the pod context, as I mentioned before, 4 pods, including the MySQL pod, are happily running. So we have basically survived our disaster.